Today we're going to have a brief discussion about quadrantal angles. So this is in the extending the domain of sine and cosine to all real numbers notes that we've been using for the past couple of days. And a quadrantal angle is basically an angle that's formed by the quadrants. So on the x-axis, positive side, negative side. On the y-axis, positive side, negative side. Okay, so based on all of the work that we've done, now let's take a look at something like the sine and cosine of an angle that has a measure of 1080. By definition, from what we've been talking about, a reference angle is the positive acute angle formed by the x-axis and the terminal side. Well, what happens if the terminal ray lies on the x-axis? Okay, well, if that's here, we can identify that point, because we're talking about the unit circle, that's the point 1, 0. Okay, so if we wanted to find sine and cosine, since technically sine and cosine are the ratio of the sides of a right triangle, in this particular case we can't really form a right triangle. But if we imagine that this right triangle was like a flat line, okay, which is not really a right triangle at all, we can still use the information that we've learned to identify the adjacent side versus the opposite side. So if you're thinking adjacent is the x-axis side, or the x value, cosine of 1080 is just a 1 value. The sine of 1080 is the opposite side, or in this case there is no y value, the y value is 0. So what you'll notice for quadrantal angles is that you're going to have values of 0, 1, or -1 depending on the position. Okay, if we look at the general rule, if you take n, where n is some integer, times 360, that's always going to bring you back to the positive side of the x-axis. So the cosine of theta would always be 1 and the sine would be 0. Okay. If we look at the second case, we're moving to the angle of 540. Okay, so 540 goes around 1 time. That brings us to 360, and then what we did in class, where we took 540 minus 360, and so we would get to 180. So if we went all the way around, we would be right back to this axis. Okay, so we have our angle in standard position, and we end up here. Okay, so now we're at this point. Well, what are the coordinates at that point? So if I'm trying to evaluate sine and cosine, cosine is your x value, sine is your y value. Okay, so you can go ahead and try that, and we'll make a general statement. So in general, if we take 180 and we rotate around back to that same position, so something that's coterminal, we will end up at the same point, which is -1, 0. Okay, so a couple quick reminders from what we've talked about earlier in this week and last week. We said that the cosine is the x value and the sine is the y value. And I told you the mnemonic that I remembered for it was that c comes before s, x comes before y, similar to how I told you my mnemonic for remembering domain and range was that d comes before r, the d are the x values, and the range are the y values. Okay, the third case, what happens if we rotate and we end up on 90 degrees? Okay, so -630, that brings us around in the negative direction, and then it brings us all the way to here. Okay, so that's essentially the equivalent of -270, which means that our terminal ray is here, and that brings us to the point 0, 1. Okay, so if we're finding the cosine of 630, we get an answer of the x value, and the sine of -630 would be the y value. So can we make a general statement? basically anything that brings us to the positive side of the y-axis will give us a cosine of 0 and a sine of 1. Okay, so of course there's only one case left, which is to bring us or have our terminal ray be on the negative y-axis. Okay, and so in this case we're looking at negative 810. So that's going all the way around. A full rotation would be 360. Another one would be negative 720, and then a little bit more, 90 more in fact, to get to negative 810, which is the same as a negative 90. So if we're at negative 90 and we have our terminal ray here, this represents the point 0, negative 1. So again, cosine represents your x value and sine represents your y value. So do you think we can make a generalization for this? Of course. If you have 270 and you rotate around and find any angle that's coterminal, whether it's going in the positive or negative direction, we would have cosine being 0 and sine being negative 1. Okay, so tomorrow we'll discuss the domain and range for the sine and cosine functions. Please make sure that you finish exercises that were assigned in class today. So that was exercises 6 through 10.